Hey there! So you know already what Dedicated SQL Pool in Synapse is. This is this good old relational data warehouse to which we can load the data and then serve it to customers, to consumers. But how do we populate this Dedicated SQL Pool with data? How to connect to it? And well, that's the topic for today, so let's get started. Alright, so the topic for today is loading data to Dedicated SQL Pool. And now I want to show you multiple methods, 6 in total, I believe, which means that I will not be able to deep dive into each of them, because simply it will take too much time, and I don't want to spend few episodes just on connecting to SQL Pool. Secondly, I will assume today a very simple scenario when we have some data prepared on a data lake and we just want to load it to a table in Dedicated SQL Pool. And the way to do this will be to delete everything from our target table, just truncate the table, and then load it from data lake. So truncate and insert. And in real life, this approach might be valid for small datasets, but for bigger ones, it's obviously not doable because there is simply too much data. But for now, let's just assume a simple scenario. Alright, so let's start with the first scenario. And it will be like this. So let me jump into whiteboard. So that's our data. So we have our data lake that we populated with data. We've got our curated layer, the last one that stores pure and pristine dimensions and models that we want to load to our Dedicated SQL Pool, to some table. And we will be continue working on our minifix data, and we already have this minifix stored in our data lake as a delta format. And basically that's the goal for today, to grab everything from our data lake and insert it to Dedicated SQL Pool. So very simple scenario. And now let me start with a pool approach. And by pool, I mean that it is a Dedicated SQL Pool who initiates the whole operation. It is pulling the data from external data source, in this case from a data lake. It is not some other service that is pushing data to SQL Pool. No, it's the pool that is pulling it to itself. And this scenario, well, it makes sense when, for example, you already had some data warehouse on premises, for example, built using SQL Server, and you had some data transformations there implemented as stored procedures. So you don't have Databricks, Data Factory, or Synapse. No, it was just a good old data warehouse. And what you want to do is to simply lift and shift this database, this data warehouse, to Azure and continue using it. Which means that you don't want to redesign your solution and move all of those transformations into Databricks or Spark pools. No, you still want to happen them, to make them as TSQL statements. And to make that work, you have to load your data that you'll be working on somehow to your SQL pool, to those staging tables. Because in this case, those staging tables, in a case of which you know you want to use round-robin replication, you can treat them as this raw layer when your data is stored in this maybe not yet clean format. And then transformations would follow inside data warehouse. In our scenario, it is a bit different because we'll be loading already cleaned data. But we can still use this pool approach. And now, the nice thing about Dedicated SQL Pool is a feature called PolyBase. So actually, let me write it down. That our first scenario will use PolyBase. And PolyBase is simply a fancy name for a possibility to query data that is stored outside of your database, like on a data lake, by using TSQL queries. So we will treat them as if they were regular tables, but physically they are stored somewhere else. Like in our case, our data is on a data lake, and we'll query them from inside of our database. Alright, so how to make this work? And well, in case of PolyBase, we've got to create some objects. So let me jump into Synapse Studio and into the Develop tab, because that's where we will be creating our SQL scripts. And one more time, Dedicated SQL Pool is about SQL statements. It's a good old-fashioned database. So let me create a new SQL script. And actually, let's call it PolyBase. PolyBase sample. And now, important thing is to switch the connection from the built-in database, we'll get back to it in one of future episodes, into our dedicated SQL pool that we have. In my case, it is DWH test, data warehouse test. Alright. So what do we have to do in order to connect, to read this data externally from a data lake? And well, first of all, we have to decide, alright, how are we going to connect to a data lake? And in this case, I will just create an object called database scoped credential. I will call it ADLS Gen2 credential. And I will indicate that, hey, dear Synapse, when using this credential, please use your own managed identity. I don't want to use some dedicated accounts, just use your own identity because you have one. So let's reuse this. So let me run this. And at the same time, let me update our diagram. So the first thing we did was to create this database scoped credential. So it was database scoped credential. And in our case, we configured it to use Synapse managed identity. There are other options as well. I will not deep dive into them because simply we don't have enough time to cover all possibilities. You can jump into documentation if for some reason managed identity is not a valid option for you. But in most cases, I would go with managed identity. So Synapse managed identity. So that's created. Great. But right now, we just created this credential. We haven't used it yet. So the next thing we have to do is to create something called external data source. So let me paste it here. And external data source is simply a definition of some external location. In our case, what I'm doing is I'm providing a path to the curated container on our data lake. That's it. So this is a path to the whole container, not to a specific directory or specific file. And I want to do this way because I know that I will be reusing this container in multiple queries. Then I have to indicate, alright, how should Synapse authenticate to this location? And take a look that we are simply reusing the credential that we've just created. And finally, I've got to indicate a type of this data source. For now, let's ignore this. So let me create this external data source and let's position this on our diagram. So what we did as a second thing was this external data source. And external data source is simply a pointer to some location, usually on a data lake. source. And in our case, what we did was to point it to this whole curated layer. And we also associated it with our database scoped credential. So Synapse would know how to connect to our data lake. So simply put, it will use managed identity for authentication purposes. All right, great. So what's next? The next thing to do is to define something called external file format. And this thing, it determines, well, what is the format of data that we want to read using PolyBase. And here is a problem, because unfortunately, PolyBase, in case of dedicated SQL pools, is not able to read Delta format. Sorry, not supported. Which means that this approach will not work. It is simply not supported. Alright, so let's try to do it differently. So instead of using Delta format, let's try to go with CSV files. And I know CSV is not the optimal format for storing data in a data lake, but for the sake of this exercise, let's just try to connect to our data using CSVs. And what I have in my data lake, in a curated layer, is that I created this minifix underscore CSV directory that contains my data CSV file. And this is just a CSV file that contains our transformed replicable minifix. So the same data as we have stored in Delta is available here as CSVs. So let's try to load this file using PolyBase. Alright, so what we have to do is to create this external file format to tell Synapse how it should interpret the file, how the file looks like. So let's jump back to our Synapse and let's create this external file format. And what I'm specifying here is that, well, the type of the files we want to read is delimited text, simply a CSV. And then I'm specifying two options. So first of all, which character is used to separate various columns. In my case, it is a comma. And which character is used to delimit strings, double quotes. And you can verify this in my CSV file, that indeed we have commas separating various columns, and double quotes are used as those field terminators. So that's fine. The thing is that, actually let me create this, because I think I didn't do that yet. Alright. The thing is that number of options that we have, that we can set for this external file format is quite limited. And soon you will see that it will cause some issues. Anyway, what we did was to define this external file format. So let's add it to our diagram. So that was the third thing. External file format. And we simply configured it to be able to read some CSV files. And please note that right now we didn't provide any path to the file. We just told Synapse how this file will look like. Which means that we will be able to reuse this file format in case of multiple files, if that's what you would like to do. Alright, great. So finally, at this moment, we will be able to create external table. And that's the object that combines all those three things together. So external table is simply this object that we will create inside our Synapse pool that will reference the external data stored somewhere on a data lake. So this is number 4, external table. And actually, let me create this. All right, so let me copy the code. Let's go back to the Synapse Studio, and that's definition of our external table, meaning that the data for this table is not stored inside Synapse. No, it lives somewhere else, externally. And let me call it replicable.minifix external. I provided a definition of this table, and please note that here I used on purpose strings for every column, just to avoid this type conversion hell that happens in case of PolyBase, in case of CSVs, because in case of CSVs, you know that every column is a string, and converting them right now to proper data type might be challenging. So I just want to postpone it to later phase. Then I'm indicating, all right, where my data for this table lives in my data source curated layer that we created a few minutes ago, that points to our curated container on a data lake. All right, but where exactly on this curated layer? Simple, under replicable /minifix CSV / my data CSV file. So that's where this file lives. And how does this file look like? Well, simply place dear Synapse, use the specification that we've just created, that it is a CSV file that uses comma and double quotes. And let me create this external table. And it has been one thing I forgot to do. Well, we defined that Synapse should connect to a data lake using a managed identity. Great. But I forgot to actually grant it permissions to be able to read the data. And that's something very important when you think about these external tables, that the security is handled and checked at 2 places. So first of all, it will be checked inside your SQL pool, just to check if your user running your queries is able to connect to the pool and has access to this database, to this table. But secondly, it will check if the principal that is used under the hood to connect to the source data is allowed to do this. And actually that's failed, because our managed identity doesn't have access yet. I have access to our dedicated SQL pool, but not to the data yet. So let me fix this. And to make this work, I will simply go to Azure portal and add managed identity of our Synapse workspace to a group that we've been using so far, this data lake contributor. And that's the group that grants storage blob data contributor role on our data lake. So read and write permissions. And let me add a new member. It will be Synapse something, because the name of a managed identity is the same as the name of the workspace. And it's this one. All right. So our managed identity has now access to a data lake. So if I retry the creation of our external table, it should work this time. So let's verify. All right, so it worked. Great. So finally, or actually before we do this, let me explicitly mark the objects that we used in case of external table. So what we did was to associate it with our external data source and external file format. So external table is this final object that combines all of those things we've created so far. All right, and let me publish this because I want to show you that this table is now visible inside our Data tab under Workspace. We already have this Lake database, and Lake database is simply a catalog of tables of objects that has been registered in our Synapse but point to a data lake. And to refresh the view, I will just refresh the browser. That's why I published my changes first, just to not lose them. And after the refresh, you should see this new SQL database category, that we have our dedicated SQL pool, and we have this external table created called external minifix external. So that's our object that points to a data lake. Data is not stored inside Synapse. No, it lives somewhere else. All right, so let's finally try to query our data. And I told you that the nice thing about PolyBase is that we can reference this external data using just regular TSQL statements, like a select one. So let's run this and see what happens. So please work, and it doesn't work. With an error that could not find a delimiter after string delimiter. Not very helpful message, to be honest. But actually what it means that it wasn't able to parse our CSV file using the format options we specified. And the thing is that inside our CSV file, let me try to find something. Yeah, take a look. So that's a name of our minifig. We encapsulated every column inside double quotes, but unfortunately, this particular row has embedded double quotes because we've got this Cara Cynthia, Cara Dion, and Cara is a nickname, I believe. And what happened when I extracted the data as CSV was to add those escape characters, those backslashes. A normal thing when you have these special characters inside your data. But the problem with PolyBase is that there is no option to specify those escape characters. Sorry, it's limited technology. And to make PolyBase work, your files, like CSV ones, have to be created in a specific way that aligns with requirements for PolyBase. And our example here simply doesn't meet those requirements. So it is kind of a limited thing. Now, if I had a nicer CSV file, it would work. I would be able to load the data. All right, but let's continue. Let's try to make this work. So maybe instead of Delta, which is not supported, instead of CSV that is not created in a proper way, let's try to use Parquet files. And actually Parquet is a way better choice than a CSV because Parquet, they contain the schema already as a part of a metadata. So let's update our code with a file format to read Parquet. And actually I have this Parquet version of our minifix available as well. So I created this minifix Parquet directory, and there's this my data snappy Parquet file. And this snappy thing, it simply indicates how the file was compressed. And snappy is one of the most commonly used compression options. All right, so let's go back to our Synapse. So unfortunately, CSV approach didn't work. So let's continue with Parquet. All right, so what we have to do to make it work is to simply create a new file format. Let's call it minifix Parquet, where we'll define that, hey, this time your type of files that you want to read is a Parquet. And we are going to use snappy for compression. All right, great. And then let's recreate our minifix external table to use this new file format. So I'll drop the table that was created so far that used CSVs, and let me recreate this with a Parquet version. And take note that this time I specified a nice table definition, because this schema lives inside our Parquet file, so there is no type conversion needed after all. And what I also changed is the path to our file, this time to a Parquet, and I changed a file format to use the one that specifies Parquet. Our data source remains the same, because data source simply points to the whole curated container. Alright, so let me run this. External table has been created, and let's try to query our data. And hopefully this time everything will work. And yes, take a look. This time I'm able to read data from a file that is stored on a data lake by using TSQL statements, just like any other table, which is super cool. Because right now your data engineers, they can use a similar set of tools, SQL language, to process, to transform your data. All right, but please remember that data still lives outside of Synapse. It hasn't been loaded. And you might ask a question, all right, so can I update our data, this external data, by using SQL? So let's check it. So I'm writing a simple update statement to update our external table and just set some dummy value. And what happens is that data manipulation modification statements are not supported. It is read-only capability, but that's fine. It doesn't prevent us from using it. So actually, let's quickly jump into our diagram and let me write some cool stuff or some characteristics about PolyBase. So first of all, it is fast. PolyBase was created to use this MPP architecture of Dedicated SQL Pool. So it loads data directly in a super fast way faster than regular insert statements. So obviously you could try to insert the data row by row, but PolyBase is way faster. Unfortunately, what we saw, it is limited. So for example, it is not able to read Delta files. It had those requirements when it comes to the structure of CSV files. It requires us to create those additional extra objects like database scoped credential, external data source, external file format, and external table. A lot of stuff that you have to create. But in many cases, it will be fine. Now, the thing is that, all right, our data still lives here on a data lake. When we query the table, Synapse goes to the data lake and grabs the data, reads it every time we make a select statement. And maybe it's not optimal approach. Maybe we would like to have this data available inside our database. And yes, this is possible. So what we'll do would be to create yet another table inside our Synapse dedicated SQL pool, to which we'll load the data from the external table. And this table is just a regular table, normal one, that we can insert, update, or delete from. And to make this work, we'll use something called CTAS, create table as select. A recommended way to load data from external tables. So how does it work? Alright, so simply let me paste a text here, a command, like this. Create table, is replicable minifix real, I know, great name. And because it is a real table, I want to provide a distribution, in this case round robin, because I want to load the data as fast as possible. And then, instead of specifying the definition of my table, I just say, please read the contents of our external table and use it as a definition of my new table, and also populate my new table with the data, with the rows that are already stored inside our external table. So let's run this. And the table has been created. We can verify that the data really exists there. So let me query our new table. Yes, it works. We should see it as well on our lists. So that's the one, this replicable minifix real. And also, because it is just a regular table, we can update data inside it. Something that wasn't possible in case of external tables. So one more time, what we did? We loaded the data to our external table and then loaded the data again to a regular table. So at this moment, if data here in a data lake changes, they would be reflected in the external table because it always returns you live data, but it will not be available in our final table because we didn't load it again after the changes. But that's fine. And basically, that's how PolyBase works, the first version. And now, about those all objects that we had to create, there's also a simpler version. So if you go to our Data Explorer, to a data lake that contains our data, so let me go to our Parquet file. If you right-click on it, you can simply generate a script that will create your external table and all of those objects. Obviously, most likely you will need to update it a little bit, but at least it will be an initial version that you can later update. So I will skip this. You can practice this on your own. Alright, so that was the first option that we have of pulling the data, this PolyBase one. The thing is that, well, it has those issues. Those extra objects is painful, so maybe there's a better way of doing this. And the answer is yes, there is. So again, our goal is to copy data from ADLS to Dedicated SQL Pool, and we are still pulling the data from SQL Pool, but this time we'll use a newer version of this pull operation, namely a copy statement. Copy. So how does it work? And let me just publish our PolyBase stuff. And let's move on to a copy. So actually I will create a brand new script for copy. Copy. Alright. And again, we need to switch the context to our data warehouse. And let's verify what we have in our final table right now, because at this moment we don't want to bother with any external tables, with any those additional objects. No, we just want to copy data directly into our final table. And in our case, this final table has this great real suffix. And at this moment, it is populated with some data from PolyBase exercise. So let me truncate it, just remove all data from this table. Yes, please. Double check that it is empty. Yes, it is empty. And let's go with copy operation. And how does it work? So it is simply like this, a very simple statement. So copy into, then we have to provide a table to which our data should be copied. Then please provide a location where this data lives externally. And here, take note that I'm just providing a path to our Parquet file without those external data sources or external locations. Just ABF, just a path to a file. And then I have to provide some options like, alright, so how Synapse should authenticate to this external location. And again, please use managed identity. And finally, what is the type of our files? Well, it's a Parquet. And that's it. And let me run this. And hopefully it will work. It did something in 3 seconds. And let me verify if we have any data. And yes, the data is there. So it was loaded very fast, very efficiently, without writing too much code. So actually, let me update our diagram. So here, actually we connected to Parquet because unfortunately Delta is still not supported for copy, but that's fine. We have this Parquet alternative. We connected to data lake using managed identity of Synapse, and it was a super fast operation. It is a very simple statement to write, especially compared to PolyBase. And if you have a choice of using copy or PolyBase, usually you should go with copy because it's a newer version. But still, it is somehow limited. It is not able to read delta. It will also fail with those escape characters. But it is a pretty good option. And actually, how long it took to load the data? I think 3 seconds. So pretty fast. All right, and those 2 methods that we've just covered, PolyBase and copy, they were examples of this pool approach, that we are inside our SQL pool and we run queries inside it to pull the data from some external source. And sometimes it is fine, but maybe you want to plug your process of loading data to Dedicated SQL Pool into your existing orchestration. So maybe, for example, you used Data Factory to orchestrate ingestion, transformation, and then you would like to use ADF pipeline to push the data to SQL Pool. So let's see if that will work. And before we go further, this copy statement, well, it supports only CSVs, Parquet, and orgs formats. So Delta is still not supported. All right, let me publish our changes. And let's go to Data Factory into pushing the code. So how this might work? Well, it would be like this. So this is our third scenario. So still we want to grab the data from our data lake to a table in Dedicated SQL Pool. And we want to use copy activity because that's the most obvious choice that should come into your mind when you think about moving data from one place to another. And we know that copy activity or pipelines, well, they exist in both in Synapse and Data Factory. So ADF and Synapse would look basically the same. Synapse. And what we want to use is this copy activity. All right. So let's jump into Data Factory, my table ADF, and let's create a new pipeline. Please create. Copy data to SQL Pool. All right. And what we would do would be, well, grab a copy data activity. And usually, as always, we have to define source and sink. Our source would be a delta file inside a data lake. So let's create a new data set. We know that it would be read from a data lake. That's fine. And then we've got to define or select a file format. But I forgot that Delta is not supported here in pipelines. So nope, it will also not work, unfortunately. So let's update our diagram that sorry are a copy activity will not work. But if you recall our previous episodes, you should remember that somehow we were able to save data to a data lake as delta using ADF. And what we did then was to use data flows, this visual way of doing transformations that uses Spark under the hood. And we know that Spark, it works really well with delta format. So let's try to use data flows and see if it will work. All right, so how our process would look like would be like this. So let's create a data flow. That would be a very simple one. We won't be doing any transformations. We just want to read delta from data lake and then save it to a dedicated SQL pool without any transformations in the middle. So it is a very, very simple flow, but it should work. All right, so let's create a new data flow. Save, oh come on, please. Save data to SQL pool. All right, and what we have to do? Well, indicate our data source. And our data source, and I will skip those names just to make it faster. Well, we can't use a dataset because we know that those datasets at the pipeline level, they don't support delta. But we know that inline ones, they do. And inline, they live only inside of this data flow. They are scoped to this data flow only. And here we should see this delta dataset type that should work. Then we should choose a data lake or a linked service where the data lives. And we have this data lake, a linked service created already. So that's fine. So let's move forward and let's indicate where on our data lake our data lives. So let me simply browse it. And we have our minifix in a curated. And I think we have multiple versions of our Delta minifix, and we'll use the one that was created by Synapse in one of previous episodes, provided that this UI will work. All right, so under replicable directory, we've got, let's say, this minifix Synapse. And please use this. All right. Now, I want to take a look at our schema and our data, and to make this work, I have to enable data flow debugging. So let me run this, and I'll be back in a few minutes once it starts. All right, so my data flow debug session has started, so let me import the schema. And again, it will also take a minute or two, so I'll be back in a second. All right, so my schema has been imported, and yes, it means that we were able to read our delta data in Data Factory. Great. And we can actually preview the data and see that those rows have been successfully loaded. And in the meantime, we should start thinking about, alright, but how are we going to connect to a Synapse? And indeed, see, we have the data available. So how do we connect? So first of all, we know that Dataflow works to connect to Delta, and we used a linked service that had managed identity of data factory configured as a connectivity method. But then we have to connect to a dedicated SQL pool somehow. And what I will do is to simplify this process. Obviously, we need to grant some permissions. So let me add a new script. I will call it security. And I will do a bad thing, because I will grant our managed identity of data factory a DB owner role on the data warehouse. And DB owner role, it means you can do everything inside of this database. And this is too much just to be able to load the data to a SQL pool. But to make it simpler, I will go this approach. In your case, please check documentation and set only the required set of permissions. Alright, so what I will do is, first of all, I will create a user for my data factory. And this is this strange syntax: create user, name of our managed identity, which is the same name as the name of the data factory, and then from external provider. And this external provider, in our case, simply means Entra. And then what I'm going to do is to grant this table ADF user a DB owner permissions. So a very powerful ones. And also what I will do will be to grant the same principle, this administer bulk operation permissions. And in a second, I will tell you why. Alright, so that's done. So data factory can connect to this dedicated SQL pool. So let's jump back to our Dataflow. So what we're gonna do right now is to simply add a sink, like so. So we've got a sink, and we know that our destination should be dedicated SQL pool. So let's create a new dataset, because right now we don't have any for the dedicated SQL pool for Synapse. So first of all, let me choose Azure Synapse Analytics as a data store, and then let's give it a name to our dataset, Minifix Data Warehouse DS, and that's fine. And then let's choose a linked service to our Synapse, and actually I will create a brand new one. Azure Synapse Analytics demo, a linked service. And here what is important is that I have to switch from recommended version of linked service to legacy, because the recommended one is not supported in Dataflows. So let me switch this. And then we have to indicate which Synapse we have in mind, which database. And this is the Synapse DP2 table demo. Our database name was DWH test. That's the name of our dedicated SQL pool. And we're gonna authenticate using system assigned managed identity. So basically a managed identity of this data factory. And we just granted those permissions, so hopefully it will work already. Yep, it worked. So let me create the linked service, and then let's indicate to which table we want to load our data. And let's choose replicable minifix. Alright, and that's it. So let us take a look at this operation, at the sync one. Let's verify its settings. And what I would like to do, well, I want to add a pre-loading script. I want to truncate our table every time we run this, because it will be loaded with a fresh set of data. So I will simply write truncate table, replicable, minifix table. All right. And the second thing that is important here is this enable staging option that is checked at the start by default. If I uncheck this, you will see this pop-up that it is highly recommended to enable staging when you connect to Dedicated SQL Pool for better performance, and this is true. So let me enable this. And what it means actually, this staging. So basically, what happens is that we'll define in a second this staging location. In our case, it will be our data lake. And what will happen is that data will be first dumped to this data lake, and then from it will be loaded to Dedicated SQL Pool in a very efficient way. And actually, this part, unloading data from data lake, we just covered. And surprise, surprise, it is done under the hood by using PolyBase. That's why I decided to cover PolyBase first. All right. So let's jump back to our pipeline. This one failed. So let's try to use a data flow. And let me indicate which data flow we want to use. It was this save data to SQL Pool. And the thing we've got to set right now is this staging. So where our data will be dumped into as a temporary location. And let me choose our data lake that we've been using so far. And I created here on our data lake this stage container that is used just for staging purposes. So let me indicate, please use stage container. And UI, please respond, because I want to use the stage container. All right, so that should be fine. And actually, we should be ready to go. So let's debug our pipeline. So the pipeline, it simply executes our data flow. Data flow, which is super simple because it connects to our data stored as delta on a data lake. It reads it and then saves it to our dedicated SQL pool, to this replicable minifix table. But to have better performance, what we did was to enable staging. And staging here means once you read the data from your source, dump it to a data lake in a format that will work out of the box for PolyBase. And you know that PolyBase, well, it requires the data to be saved in a specific way to be able to load it. And that happens automatically. Data flow is taking care of converting our data to a format that should work just fine. So let's wait for a second once it finishes and see if it went fine. And take a look. It succeeded and it took 1 minute 20 seconds. So actually, let us write this time 1 minute 21 seconds. And it included, I believe, the startup of our Spark pool that is used under the hood. And if we go to Synapse, and actually let me add a new script, we should see that if we query those minifix table, we should see a data that has been loaded by our data flow. And at the same time, if we take a look at debug or data flow details, we should see that yes, those 14,000 rows were written to our dedicated SQL pool. So that's a way how you can save the data to a Synapse dedicated SQL pool from Delta using Data Factory by leveraging Spark under the hood. And actually, there is one more method that you could try on your own. So if you use copy data, there is this Databricks, this one, Azure Databricks Delta Lake and Data Store. That again uses Spark as Databricks cluster to connect to a Delta Lake and read the data. So if you want to, take a look if this connector would work in your case and what is required to make it work as a homework. Alright, so this was how to do this from Dataflow. Alright, but I would still like to show you this copy activity because it has some nice configuration options that I want you to be aware of. So what we'll do right now would be to use a copy activity. So again, you want to copy data from our data lake to dedicated SQL pool. So copy activity will be used that is available in Synapse and Data Factory. But we know already that to make it work, we have to use a different format because Delta is not supported. So let's do this with CSVs. That's fine. And see what options we'll have with CSVs. So actually, let me jump to Data Factory and let's create a new pipeline. Copy activity to SQL pool. Alright, and what we have to do is to, use a copy data activity. That's obvious. As a source, let's see if we have an I think this one, this minifix CSV dataset. It connects to our data lake. Let's see if yeah, so this one would work. I just need to update a path. So it was curated. Oh, come on. UI is not responding very fast today. Minifix CSV. And this my data CSV. So that's my data I want to read. Let's verify that it is able to read this. Yes, that's fine. And please note that here in dataset, we have those additional options that were not available for PolyBase, like define explicitly our escape character, because our CSV file, it still has this issue with double quotes inside our text. But Data Factory is able to handle this without any issues. Alright, so this was our source, and as a sink, well, we should be able to reuse our data set. Yes, we should. So again, let's truncate our table, rubricable minifix. All right, and let's make sure that staging is enabled. Or actually, let's go with some defaults. And because we are reading a CSV file, I want to make some explicit configuration. So especially for this last modified datetime column, we know that it is actually a datetime. So let's treat it as a datetime, but to parse it correctly, I will expand this properties and set the format that should be used to parse this data that is saved as a string to be able to convert it to a datetime. So that's how to use it. All right, and let's revisit our sink and take a look that here we can choose how the data should be copied. whether we want to use copy, and copy is the same option that we covered at the beginning, or PolyBase, which we also covered, or bulk insert, that's the older method of inserting data in batches, or the worst method of upserts. So basically we'll focus on those two. And we've got some additional settings. Right now we have staging disabled by default, so let's try to run this. And unfortunately, take a look. We got the instant error that in our case we are not able to copy data directly using this copy operator because our source data is not formatted in a way that is supported by copy operation. And what we have to do to make it work is again to enable staging. So we'll do this. So what it means? Basically, again, we'll use our data lake as a staging location, and data will be saved to it in a form that later on could be used by copy activity, because we want to start with this copy method. All right, so let's do this. Let's enable the staging. And now, if our data, our source data, CSV, was formatted in a way that is supported by copy operation, then we wouldn't have to use the staging. But because it's not, let's configure this. And here we'll simply reuse our ADLS Gen2 linked service. And inside it, we have our stage container that we want to use. All right, and let's run this. And let's see if copy will work. And I will be back once it finishes. All right, and our copy activity succeeded. It took 55 seconds to finish. So actually, let me write it down, that copy took 55 seconds. And if we check the data inside our replicable minifix table, it should be there. Yeah, it was just loaded. And we can also take a look at some details. And here you can see explicitly that we use this intermediate staging location. That first data was read from our source location to the staging location, and then from it, it was loaded to Dedicated SQL Pool. So that's how it works. And now we can also take a look at our staging data. So that's our stage container. And you can see this directory that was used by our copy activity. It is empty right now. There were some files created automatically, and then they were cleaned. But apparently the directory was left. All right, so that was copy activity. Copy activity with copy data method configured. And usually that's what you want to choose. A copy is the best option out of those available here. But let's also take a look how PolyBase would work if it would change anything. And again, what I had to do was simply change the copy method to PolyBase and let me run this and see if it will work. So I'll be back once it finishes. All right, and the PolyBase version succeeded in 42 seconds, so a little bit faster. So basically, these two can be compared, are similar when it comes to performance. So it might depend on your data how fast it would be. Usually, from my experience, copy is faster, but here actually it's the opposite. So PolyBase took how long? It was 42 seconds. 42 seconds, and it succeeded. So if we take a look at the data, well, we should see it again, that everything went fine. All right, so that's how you can move the data from data factory. Great, but actually, maybe we would like to push the data from our Spark. And because when we were transforming the data and saving it to a data lake, we already had it available. And we know that Spark can read Delta very well. So the question is, are we able to connect to our dedicated SQL pool from Spark pool and from Databricks? So let's check this. So actually, let me create a new notebook, like interact with SQL pool. Let me plug it in to our Spark pool, and let's try to connect to the dedicated SQL pool. And actually, you can simplify it a bit again by using this right-click operation. So if I go to our data, to workspace, to some table like minifix, you can have this new notebook load to data frame option. All right, and what it did was to generate this Scala code that uses a very simple statements to connect to our replicable minifix table and read its content to data frame called df. All right, but we can reuse this code, but I prefer Python personally. So actually, let me remove this and let's go to our notebook and let me simply paste a code that I found in documentation. So actually, what we have to do is like this. I will run it and then I will explain what it does. So first of all, we are importing some package, this SQL Analytics, that contains a connector, Spark connector, that can be used to connect to dedicated SQL pool from Spark pool. And then I'm using the same method that we saw in the Scala code, this Spark read Synapse SQL, and then I simply provide a name of our database, then schema and table. So basically, this is our table, our database. And because it is under the same Synapse workspace, it is so simple to connect, to use this method. And actually, right now what I'm doing is that I'm trying to read data from my SQL, from my data warehouse table, and it should work in a second once the cluster starts. And actually, this possibility is super important because usually, or sometimes when you do your transformations using Spark, you might need to refer to data that is already stored in your data warehouse. Maybe you have some dictionaries there, some master data, and that's the way you can do this. All right, so let's wait for the Spark pool to start, and then I'll be back. All right, and our query, our cell has been executed. We read the contents of our minifix table from SQL pool to a data frame, and we were able to display its contents. Great. So what next? Well, actually, let's save this data to a SQL pool. So let me add yet another cell. And let's do the code like this. So let me take the content of our data frame and let me simply append it, so insert it to our minifix table. So basically I will double the count of rows. So let's verify how many rows we have right now. It should be 14,000 if I recall correctly. Yep, it's 14,000. And if we go to our cell and let's run this, what it will do, it will grab our data frame with minifigs that we just read, and it will insert them again to the same table, which effectively should double the number of the rows inside our table. So that's the way how we can write data from Spark to Dedicated SQL Pool in a very easy way by using this write Synapse SQL method. And it finished, and if we recheck the count of our rows, it doubled. So that's a proof that indeed we were able to connect. So actually what we did was like this. So this time we were able to read data from Delta format, and we used Spark pools. And to make this work, we used this very simple syntax: Spark write Synapse SQL. Great. But actually, under the hood, it again used copy operation. We don't see this, but there is a staging data lake used, to which data was dumped automatically and then saved to target table by using again copy operation. And probably you're wondering, all right, but where it was staged? We didn't provide explicit staging location. And yeah, that's true. We can do this. But if we don't, the default location is used, and let me simply check where this staging directory is. And in my case, it is simple. It is simply under the primary data lake that is associated with this Synapse workspace. So it is there, but it was handled automatically. But take a note that in those all options, staging is used, and either PolyBase or copy operation is performed. All right. And the final option I want to talk about today is Databricks, because, well, personally, I prefer Databricks. I like it way more than Spark SQL pools. So the scenario is like this. We've got our Databricks workspace. Maybe that's the one that we used to save the data to our data lake as Delta, and now we would like to read the data from it and just insert it to Dedicated SQL Pool. So how to do this? So I have a notebook created that is executed on my demo cluster, the same that we used previously. And first of all, I'm starting with some initial configuration that tells, all right, how do you want to connect to your data lake and to Synapse. And basically, we'll use the same method as previously, the secure one. We're gonna connect using a dedicated service principal that we created in previous episodes, and we stored its secret in a key vault that is available here inside Databricks. So let me execute this code. So that is just a configuration. It also means that, well, we need to grant permissions to this service principal. And actually, let me go to our security script. So for Databricks, what I'm gonna do is like this. Let's create yet another user for this Databricks service principal. That's the name of the principal that we've been using previously. And let's add him to this DB owner role, and let's grant it administer database bulk operations permissions. Again, too much permissions, but to make it simpler, let's just go with this approach. All right. Then let me verify that I can still query our data that is stored on a data lake. This Piotr demo minifix, that's a table registered in the Databricks catalog that refers to the data stored on a data lake as delta. And yes, I'm able to read this. And now let's write the data to our dedicated SQL pool. And what I'm going to do is to use this specific format, SQL.dw. And again, like in case of Spark pools, there is this dedicated connector created for Databricks that allows us to connect to dedicated SQL pool. Then I have to indicate, all right, to which pool and to which database I want to connect. So that's the address. And then I'm specifying a staging location. So again, this connector uses temporary location to which data is dumped, and then from it is loaded. And then I indicate, all right, so to which table I want to read the data, write the data, and do I want to overwrite or append? And this time I'm using this replicable minifix real table. So actually, let's see if we have any data in it. We should. Yeah, but how many? 14,000 rows. All right, so if I run this, we should add yet another 14,000 rows to this particular table inside our dedicated SQL pool. And it finished in 9 seconds, so pretty fast. And let's verify that the number of rows doubled. And indeed, it happened. So we were able to connect from Databricks to our dedicated SQL pool. And the same, we can read the data from SQL pool to Databricks, and then just operate with this data in a way we want. So it is a two-way connector, two-way connectivity possible. So again, how it works is like this. We have this staging data lake configured, to which we dumped the data, and from it used under the hood copy operation to grab the data. And when it comes to authentication, well, we used our service principal, this Databricks service principal, in every case to connect to those locations. All right, so that was it. So to summarize, I know it was a long episode. So we covered those 6 options that we can load data to dedicated SQL pool. And that's something that you have to know how to do this, because that's the goal of pool, to have the data available to be served to your customers. And we had, first of all, those 2 pool methods where the operation is initiated by SQL pool itself. We've got PolyBase and copy. Each of them, both of them are pretty fast. But in case of PolyBase, we had to manually create those additional objects like external data source, external file format, external table, which is not super fun. And then to persist the data in our data warehouse, we use this CTAS create table as select statement, which allowed us to read the data from our external table and save it physically inside our table. But unfortunately, it doesn't support the delta. And the same with copy operation. It still doesn't support delta, but at least in this case, we didn't have to bother with creation of those additional objects. And then we moved to those push methods when it is someone else who is pushing the data to SQL pool. And we verified that copy activity, well, it cannot work with Delta, it's not supported, but we used a workaround to create a data flow. Very simple one, just read the data from a data lake and dump it to SQL Pool, and that worked. Then we used copy activity for CSV files. And we had this option of choosing a copy or PolyBase methods to actually copy the data, and both of them worked. And finally, we verified that we can connect to SQL Pool from Spark, either from Synapse Spark pools or from Databricks notebooks. And basically, that's it. So thanks for watching and see you next time. Take care.